Once you have all your parts 3D printed and servos, actuators, screws, etc., we can go ahead and get started with the assembly of the forearm. For the forearm, we're actually going to start with the elbow piece and put the inserts into the lower forearm piece, and while we have the soldering iron hot, we're going to put the inserts into the servo hood as well. So let's go ahead and start that. Alright, now we're going to go ahead and screw this piece in. This is for the elbow. We're going to go ahead and screw this piece into forearm piece 1. We do this before we put the servo in because you need to screw past, and it's just easier when that's not in. Most servos nowadays come with these guys. These aren't that useful to me, so I use these servo horns. If you don't have these lying around from some spare servos, you can buy other ones online. You don't need this. So now that those are flush, before we actually screw these in, I'm going to apply a little bit of super glue because for the elbow, this holds a lot of weight as this is turning. Just in case one of the inserts is not as structurally sound as we'd like, the super glue just gives it that added strength. It doesn't actually matter which orientation you have this in because it's pretty much symmetrical. This looks like it's it is at an angle. It looks like, you know, this should matter which way it goes, but it really doesn't. All right, now we can go ahead and screw the servo into here. As you'll find, this tiny opening, that will line up with this other elbow piece. This is the second elbow piece. This is designed to be printed symmetrically. This matters whether you're printing a left or right hand, but this opening should line up, and no matter what orientation you have it between these two pieces.
An important point about part symmetries. Some parts, it doesn't matter if you're creating the left or right arm, it'll work the same regardless. Some parts, you need to be mindful of which orientation you print them in to make sure that they fit correctly with the surrounding parts. This chart outlines every single piece used in this design. Some of them are symmetric, such as the finger design. So it doesn't matter if you're printing a left arm or a right arm, just throw that on the printer with the proper settings and you'll be good to go. Other parts, like the hand, are defaulted to the left arm. So you'll need to make sure if you're printing the right arm that you mirror this in your slicer. If you're printing the left arm, then it doesn't matter anyway. It's defaulted to that, so just throw it on the printer and you'll be good to go.
All right, that's in pretty secure. Be careful. We're gonna set this aside for now. Just don't break these off. It's not the end of the world if you do, but I've done it before and it looks cleaner if you don't. Next we're gonna move on to this. This is the second piece of the forearm. You can probably guess it sits right here. We need to attach a servo horn to the end of this as well. I've adapted this for a little star servo horn, which I have lying around. You can adjust this file however you want, and hell, you can even glue something like this. That would probably end up doing fine. But I drilled out this, so I'm gonna go ahead and screw this in and apply a little glue as well for good measure. And this will attach to the forearm piece 1. So it turns out in my case, I didn't even line up the screw holes perfectly. That totally happens. So I'm gonna end up going with a just gluing method in my case anyway. It happens. You don't get every measurement right on the first time, or the second or third or fourth in a lot of cases. But make it work. It's the spirit of this video. Okay, next we're gonna move on to the servo hold. We're gonna put the servos in here. I'm using 4 servos. The link to these, which I'm using, which are 270-degree servos at 20 kilograms of torque. I just got them off Amazon. Any servo will work, so use whatever you have available. Be mindful of the diameter of the rotating servo horn, because that does depend on the angle rotation. But in general, there's a bit of leeway. It doesn't have to be exact. So these are all the same size, even though the fingers technically have a different, require a different stroke to close individually. But it ends up working. Notice that the first servo sits a little lower. So there's a cutout here. That is intentional. This doesn't matter. You can use whichever way you want. Whichever way you choose for your initial one, just make sure you stagger them. So don't have them all going the same way. Otherwise, these will bump into each other when you start putting these on. Alright, so I just have a regular sweep function on on this servo board. So let's verify that all of these work. So I am building a right arm, which means the palm up position is going to be rotated that way, all the way counterclockwise. If you were building a left arm, the palm up position would be all the way clockwise. So when you build it, you want to make sure that the palm up position, it doesn't end up going that way. The normal range of motion should be 270 all the way up. Okay, now we are going to fix these 3D printed servo attachments to the regular servo horns. These will be what we actually tie the fishing line into to actuate the fingers. Like other components, you have the option to screw it, glue it, or both. In my case, I don't really have any screws that are this small, so I'm just going to be gluing it. These go on the underside of the servo horn. So you want to go on this side. You want to come up on this side. You do not want to glue it on the front side. Now we're going to shift gears to the hand. Make sure you keep track of these, don't mix them up. They all look very similar, so it's easy to. The best method is just to take them out one at a time. trimming of the servos. So I've already cut these and I'll be extending them here. Before you cut them, just make sure that you already know where you're going to cut them, because you can't undo it. So the normal servo lengths, as you can see like this, are not long enough to make it out the end of the shoulder. So you need to lengthen them. You have a couple options to do that. You can either lengthen them with some general servo extension cables like this. That's fine. You can also combine the positive and negative terminals of the servos, because the power will be the same for all of these. And you can just separate out the signal wires, have those positive and negative terminals go to your power supply, and then plug your signal wires into your microcontroller. So that's what I'm going to be doing in my case. Make sure that whatever cable you choose, if you end up going this route, is sufficient to handle the current going to all the servos. You can also mix and match these methods, as I mentioned earlier. So you could use 2 of these, or even combine just 2 of every servo power outputs, which might be okay in your case. Now we're going to put the servo hold into the forearm, but before we do that, we need to attach this forearm piece to this forearm piece. So this is a two-step process. Firstly, let's thread most of the wires through just to clean it up a little bit since they have to go through anyway. And then we'll actually screw this servo horn into this servo. So let's go ahead and start that. Okay, now we've threaded it through, and now we can just go ahead and screw on the piece. If you'll recall from earlier in the video, I mentioned to keep this servo in the palm up position. So that helps us now. We don't have to plug it back in and check and make sure this servo is in the correct orientation, because it should already be. Now we can go ahead and put the servo block into the forearm, since there's nothing getting in the way. All right, there we go. So now those are screwed in. And next we'll move on to connecting these wires for the finger to the individual servos. I'd like to say a word on the cable extensions. I recommend not doing it the way I just did it. Actually, what I'd recommend is threading the servo cables through and then cutting them, combining them, and extending them after you've already threaded them through from over here. It's probably easier instead of threading them through here and when it's half out, half in, trying to do all those extensions for that. All in all, the connections should hold in this case, as long as you keep track of what's positive, what's negative, and what's a signal wire, and you adequately label them, and you can go back after the fact and check. You should be all right. I still do recommend extending them and combining some as it happens, because the reason I say that is these are all threaded through this small opening, and then when we attach this to here, they all have to be threaded through this small opening here as well. For 5 servos, 3 cables each, you're going to be looking at around 15 wires. If you combine all the positive and negative for each of those servo wires, they each need to maintain an individual signal cable, then you can cut that down to 7 wires in total. So 7 versus 15 wires, that will make a huge difference when you're threading it through these small channels. I've tried to make it big enough. You could probably do it either way. You could probably fit 15 cables through here, but it's extra work. It might not hold over long periods of time, so that's why I recommend.
So before we mount these servo horns to their corresponding servo and tie off the cable so that these servo horns are then pulling the fingers closed, I want to go over the positioning of these and which channels you should use to make sure you don't make any mistakes that I've probably made along the way. So these are the two configurations that are possible. By this I mean you can use either of these two bottom servo configurations, which are just mirror images of each other, with either hand. What does matter are a few things with the servos down here. So let me clean up the view and show you. So the first key fact is that this front servo will use this center channel in either configuration. So if this was flipped the other way, it would still use this center channel. This center channel is offset, so it sits a little lower than these other channels because this front servo also sits lower. You need to make sure that this, since you're using this center channel, you need to make sure that this servo is all the way counterclockwise. If we go over here, the open position of this servo is the other way. The open position of this servo would be all the way clockwise. For now, just know that everything I describe on this side is just a mirror image of on this side. So I'll stick to this side. So because the open position of this servo is all the way anti-clockwise, so it's all the way in this direction. So once you've mounted it, as you'll see later on, so once the cable that comes through here sits around this and is tied off through this tiny hole in the servo horn, then when you close this servo, it will turn clockwise and it will pull the cable as such for whichever finger it corresponds to, and it will close. And then when it opens, in that case, what you're seeing on the screen, when that goes all the way anti-clockwise, it will open. The other servo horns and positions that are of note, this servo horn corresponds to this inner channel. This back servo horn corresponds to this outer channel. The reason for that is so there's no conflict. Because these servo horns sit very close and in line, you need to make sure that the cable for this back servo horn doesn't run into the cable for this front servo horn, which is why this channel is offset to the right and down just slightly. This servo horn will use this channel. And if you've been paying attention, you'll notice that in this configuration, no servo uses this channel. That's completely okay. The reason for that is that this piece, the servo hold, was designed to be symmetrical. You could probably also guess that these servo position configurations should be similar and analogous to the way we handled this first one. Because this servo is using this channel and this servo that channel, you need to make sure that both these are all the way anti-clockwise, so that when they close, they turn clockwise. On this side, the open position is all the way clockwise, and to close its corresponding finger, it will turn all the way anti-clockwise. I hope that made sense, and let's go ahead and mount these. So I have each of these servos hooked up to just a simple program where I can put them in either 0 or 180 position. Even though these are 270-degree servos, the 0 to 180 value is a bit of a legacy input for servo code. All you need to know is that 0 corresponds to all the way in one direction, and 180 corresponds to all the way in the other direction. So first, let's go ahead and route these wires through. So the ring and pinky are going to be mounted to one servo. I'm going to go ahead and assign that to this back servo. This middle finger, we'll go ahead and assign to this front servo. This thumb cable is already routed. This will go to this servo right here, which leaves us the pointer finger going to this front servo. Be sure when you do this that your cables aren't overlapping in this area. They should all go directly from where they exit out to their corresponding channels, with the one exception of the ring and pinky finger, which are routed together. So
So if those touch each other, that's not a big deal. Go ahead and do these one by one. So let me open up my program here. Let's put whatever servo is attached into the 0 position. Okay, so this looks like this is going to go to the thumb. So now I know this is going to be in the open position. So what I'm going to do is route the cable through. Bring it to the approximal length here that you'll see it. And then go ahead and mark it where it is. So with this still attached, where that mark is, I'll go ahead and tie a knot right around there. You can double knot it for good measure, just to make sure it doesn't slip back through the hole. Now cut this wire. Don't cut it too close to the knot, because it can undo the knot. So this should sit nicely into that bottom space. I'll screw this in a moment, but let me give this a go. Test rotation just to see. All right, so that looks good. I'll screw that in a moment. Let's go ahead and do this. Point your finger. We're going to do that the exact same way. All right, let's put this in its open position, which will be all the way clockwise. Now go ahead and mount it. Make sure when you mount it, the cable is taut, but the finger isn't really closing. You don't want it too much slack, but you also don't want its open position to be partially closed. Let's go ahead and give it a test run. All right, that's pretty good. Let's go ahead and screw these in before we move on. Okay, now we're working with this second servo here, which corresponds to the middle finger. All right, let's give that a test pull. All right, looks pretty good. I'm happy with that. And finally, we'll go to the ring and pinky finger, which are connected. So I actually trimmed this a little short and prematurely. It wasn't a complete deal breaker, but this is, see, it's touching this servo, which you generally want to avoid. In my case, there's not much I can do about it, but let's go ahead and give it a test run. All right, there we go. So now each servo is connected to its corresponding finger. The wrist servo is operating normally. The one thing we do have to do is to extend this, but you'll do that with the same process you extended the servo wires for these as well. So that's just about everything for the forearm. We can move on to the elbow next. Let's go ahead and attach this piece to the forearm. This is for the elbow. A few things to notice about this is this section, which I'll get to in a moment, and this channel, which all your servo wires should go through. What you'll also need for this step and for a few other parts of this design are some bike shifter cables. You can get these at Walmart, Amazon, most places. You can get them secondhand. That's fine. You might be able to use brake cables, so the brake sheath and the brake cables themselves from bikes, but I think shifter cables work a little better. They're pretty cheap, and I'll show you how we attach them. For this step, we don't actually need the sheath. We just need the cables themselves. But the cables run through this sheath. So we have two cables here, and you'll notice that they both come with these terminations. So these are going to sit in here, just like that. And then this one is going to sit in here, like that. And they should both sit on this groove along the outside. You need to make sure that you put those in before this actually goes on. So for now, first thing I'm going to do is I'm going to thread these wires through. You should notice that the holes line up. But in addition to screws, I'm going to apply a little bit of super glue to the inside here. Try not to get it on the cables, either the metal cables or the electrical cables, but it can really add strength to the part instead of just relying on these screws to bear the weight.